Yeah, I didn't add this to the stage earlier. Okay, so we can. I didn't add this to the stage earlier. Okay, so we can. I didn't add this to the stage earlier. Oh, I hope you have been hearing me. Oh God. Hopefully you have been hearing me. So sorry. I didn't I just came on stage. So yeah, let's continue. So API design is complicated. After all, if it were easy, there will probably be little need for this book. Seriously. We start in chapter 1 by defining so introductions to APIs. This chapter covers what are interfaces, what are APIs, what is resource orientation, what makes an API a good one. So what are web APIs? So an API defines the way which computer systems interact. Two computers, they need to interact. So how do they interact? So the kind of way they interact is through an API. And since an exceptionally small number of systems live in a vacuum, it should come as no surprise that APIs are everywhere. Anywhere you go, you find an API. That's true. That's the truth. We can find APIs on the libraries, in the libraries we use from language package managers, blah blah blah. Okay, okay. Let's look at this. Function encrypt input string. And technically in the code we write ourselves. Even if it is never intended for use by anybody, there's one special type of API that is built to expose over a network. Let's move. So So you say imagine a web API that allows you to encrypt a data. If the thing that works on the API decides to use a different algorithm when encrypting your data, you don't really have a choice in that matter. Actually, you don't have a choice. They tell you send us this data in house. You are going to encrypt it, then return, give back the encrypted data. Whatever they do with that data as a machine, because I used to let me show you this. Maybe I should share my screen at this point. Let me show you this in case. Uh, okay. Let me share on my screen. Present. Uh, mm, Let me share the stop screen. I have to stop screen before I share. But let me let me share screen. Entire screen. Let me share entire screen for this sake. I mean, let's just share entire screen for now. Do you get it? So I want to show you this. You know, let's say this is a system. This is a system. Let's say this is our API system. You give it your inputs, and what it gives you something else. It gives you something else. This is your input. So you don't really know what is inside this box. You don't really know what is inside this box. That's just how it is. That's what the book is saying. That let's say you want to encrypt my name now. Let's say my name. It's just going to give you something like ABDFZQI. Whatever they did inside this box, inside this system that gave us this, you don't know. Whether this is valid, whether this is not valid, you don't really know. So that's what an API system is. Like that's what the author is saying here. So that allows you to encrypt data. If the team that was on the API decides to use a different algorithm when encrypting your data, you don't really have a choice in that matter. You don't. When calling the encryption method, your data will be encrypted with the latest algorithm. In a more extreme example, the team could decide to shut off the API entirely and ignore your request. That's possible. They might anything can happen in this box. Anything can happen in this box. Do you get it? Anything can happen in this box. You don't know what is happening here until they tell you, maybe whether it's an open source or something. But you don't have control on this. You give an input, this is an output. And what an API does is, how it is formatted is, they tell you how you should send these inputs. It can be in different way. They tell you how you should send it and put it this. So yeah, let's move on. Why did it zoom? Okay. So is something pressing down? Let me check this. Remove this and okay, better. Yeah. What makes a good API? Where am I? So we are here. In a more extreme example, the team could decide to shut off the API entirely. At that point, your application will suddenly stop working and there's not much you can do about it. Both of the seniors are showing his behavior. So okay, I think he has given us something to is there a pen here? These highlights, but it's not highlight I'm looking for. I'm looking for no. Sorry, that's not what I'm looking for. Comment. There is pencil. Okay, I think there is pencil. Oh, good. I can work with that. Where is the eraser? On this eraser, I don't like it though. So there's pencil here. Now, what we are saying is this is you in this scenario, right? This is you. This is the server that has the API. And you send your data hello world. You see what they are returning here now. Can we zoom? I can't zoom yet. So they send their data hello world. Let's use this to zoom. Too much. Let's close this guy. Yeah, that's out of the way. So they send this thing for you. They send this. So later in the day, send later that day you send the lower. They send this. You see what I was saying now. Now they later the day now you now send a lower. They return this. See this one. You see that what is here is different from this one. You see because the encryption something has changed. They've changed their own system. You don't even know what is inside. It's more just like a black box. Do you get it? So, and later the day they shut the service down, no response. So that's how it can happen. Let's move on. Let's move on. However, the drawbacks of web API for consumers are often the primary benefits for those building APIs. The drawbacks of a web API for consumer are often the primary benefits. Okay. So what it's trying to say is, if a consumer is facing a drawback, then those that are building it, they can leverage on that to provide much more safer API. They're able to maintain complete control For example, if the encryption API used a super secret SNA algorithm, the thing that built it would probably not want to just give that code away, you see, to the world in the form of a library instead. Yeah. So API also help you to hide things. Do you get it? Unless it's an open project, open source, where the source code is being reviewed. Do you get it? It's being maintained openly or something. But if as a business or something, they will just expose the way you can enjoy it. You know, you can the way you can enjoy it. But the technology, the idea behind what happens is behind closed doors. Yeah. So expose the functionality, you see, expose the functionality of this particular within. So you see now, this is not the box I drew for you during that time. The web API, this is the server, this is the backend, whatever, whatever. This is the consumer. You in this scenario, then you make the call. The server handles it. Whatever is in this place, you don't really know it. You get it. Then you what? You return it. Like now, this user wants to detect, they want to recognize this face, they want to process the face of the user. So this is the system that can process the face. So instead of you to even build your own API system, you can leverage on this. You can leverage on this. You don't waste your time building this. Let's say you have a system, you build the face detection, you build something like Stripe. No, no, no. You can just leverage on what other people have built. Faces detected, they return it to you. So the code here, you don't know it. The code here, you don't know it. You don't know it. So nah. So why do API matters? You see, it's not uncommon for software to be designed and built for human use exclusively. There is nothing fundamental. Let's go to the myth. Here, when we design something exclusively for human use, where our interaction involve a mouse and a keyboard, we tend to conflate the system's layout feature aspect with raw data. This is a problem because it can be difficult. And this problem gets worse because changing the visual aspect of the program may also require us to reteach the computer how to interact with the new. So APIs are interfaces specifically for computers with important properties to make it. For example, interfaces have no visual. But this doesn't stop at simple automation. APIs also open the door to composition. This allows us to treat functions like Lego building blocks. Yeah. So yeah, sorry, I have a message. But this leads to important question. How can we make sure APIs will build fit together? Yeah, so like I was saying the other time, like a Lego block, let's say you have a kind of business, you need face detection, you need face detection, you need payment service. You shouldn't build this thing yourself. And the way it works like a Lego is after the face has been detected, we are sure that this user is the user that we want to pay. Then the next block will be what? Will be this. Then we go into the payment system. Do you get it? Or even if you change your interfaces, let's say if you change your interfaces, that doesn't change what the API is sending. Do you get it? So no matter how you rearrange your interface, you can still the API is still there for you. You can still how will I put it? It doesn't give you a kind of downtime. Do you get it? You just know that okay, this property that I'm getting back from the API is going into this side of the visual. So let's move on. We'll get to it. Okay, so but it doesn't. Let's see. Many web APIs that exist today act a bit like servants. You ask them to do something, they go off and do it. For example, if you want the weather for our hometown, we might order web API. Do you get it? Postal code of where you want to get the weather for, or you want to predict the weather for, if it is tomorrow. But when you say predict now, you can say this is not complete. This argument might not be complete, or it can be complete, because when you send this, depending on what this guy is going to return. What if I want for 2027? We are in 2024 yet. So what is it I want for 2027? How does this function? How does this API know what to return? So we might also add something here and say year. And say year. 27, 2027. It's just a way for you to control what the API does. You can also control it by what you put in, what you put inside. This style of rendering another computer around by calling a prefigured subroutine or method is often referred to as making a remote procedure call, because we are effectively calling a library function or a procedure to be executed on another computer that is somewhere potentially far away or remote. The critical aspect of API like this is primarily focus on the actions being performed. That is, we think about calculating the weather or encrypting data, each with an emphasis on doing something. APIs actually do something, and one of the ways you design good APIs is, or let me say functions, because these functions, naming functions, is to use verbal things, verbal names. Predict weather. You're asking it to do something. You are naming. If you name it weather, it's still going to work, but it's not intuitive. It's not self-explanatory. But if you say predict weather, everybody that sees that knows what the function or the API is doing or is going to do. So why aren't all APIs RPC oriented? So one of the main reasons has to do with the idea of statefulness, where APIs can either be stateful or stateless. Stateless deals with memory system. Stateful means it has memory. It has memory. It has a state. It can remember the state it was before you called, the state it was when you called the first time, the state it was when just called it now. Stateless is I can't remember what we did the last time. Do you get it? An API call is considered stateless when it can be made independently from other API requests. That's what I said. Independent from other API requests, because you've made the first one, there's another one, there's another one. So the first call that I made should not necessarily affect the second one I'm going to make. Do you understand? So because I got three the other time, as a result, it's not that that three will now be used somewhere around my next call. So they are stateless. We'll get there. That you now see the REST API. The S there is what? Stateless. Yeah. For example, a web API call to predict the weather involves only one independent input, the postal code. Okay, we have the postal code, and would therefore be considered stateless. On the other hand, a web API that stores users' favorite cities and provide weather forecasts for those cities has no runtime input, but requires a user to already have stored the cities they are interested in as a result. This kind of API request. So stateful is they've stored what you have done before. The postal code that you put before is what I'm going to use to process your next request. You see, it's not stateless, it's stateful. Yeah. So I'm going to end this in 10 minutes. I think we've been able to touch some things there. If you happen to be familiar with REST API, see, it's not talking about REST API. Now might be a good time to point out the section is not about REST API and REST APIs specifically. This section is not for that, but we can touch them. In other words, while there will be a lot of overlap with the topic of REST, this section is a bit more general than REST. To see why this is, let's consider an example of a stateful API for booking stateful. Yeah, let's consider stateful for booking airline flights in table 1.1. We can see a list of RPCs for interacting with the airline. So what are resource? Okay, no, sorry. Now we want to deal with what RPCs, remote procedure calls. Summary of methods for an example flight booking API. Schedule flights, schedules a new flight. Yeah, reschedule. You want to reschedule. You want to cancel. You want to show your my bookings. Each of these RPCs is quite descriptive. Yeah, thank you for that word, descriptive. We know what they are doing because of the way they have been named. But it's not escaping the requirement that we memorize these API methods. Okay. Sometimes the method talks about flights, and other times it operates on a reservation. We also have to remember which of many synonymous forms of action were used. For because the scheduled flight could mean you want to reschedule your reservation. You've reserved a flight, right? Now you want to reschedule it, but they are synonymous. But I think the better one is reschedule flight. So that's why it is saying that. You just have to remember it. Actually, there should be documentation, and in that documentation, you know the exact name, the method, the endpoint is called. Do you get it? Yeah, I'm speaking most because I build REST APIs most of the time. We also have to remember which of many synonymous forms. For example, we need to remember the way we sell our bookings, show flights, blah blah blah. Now, resource orientation. What does it help with? Resource orientation helps with this problem by providing standard set of building blocks when designing an API into it. First, resource-oriented APIs rely on the idea of resources, which are the key concepts we store and interact. So those resources will be named. Resources basically is we'll still get there, but let me just say it now. It's just something that you are interested in. I'm interested in a flight. That flight is a kind of resource. I mean about flights. So flight is a resource. Do you get it? If you are interested in weather, maybe there's a system that deals with a lot of things. So you are interested in weather. Weather is a resource. Um if it's just a system for weather, temperature is also a resource. You can break it down and say temperature because there are a lot of things that we can talk about in temperature. So temperature is a resource. Second, rather than using arbitrary precedence for any action, thinking of this a bit. So you see, create resource, get resource, list resource, delete resource, update resource. So yeah, I think this is like crowd. You want to create, you want to read, this also read because you want to list it. You're also reading it. You want to delete, you want to update. So basically that's crowd. That's crowd. If you go down this route of special limited RPC, this means that instead of a variety of different RPC methods shown in table 1, we could come up with a single resource, flight reservation, flight cancellation. So everything, instead of now saying flight reservation, do you get it? We can be so sure of what we are dealing with. So we are talking about flight reservation. These are our resource. So you can create what? Create resource, you can get resource, you can list resource, you can delete, and you can what? You can update. So that gives you all this. So different from what we had there. No, not here. What we had there. So somewhere is talking about flight, and now it's talking about reservation. This one is talking about booking. This one is talking about trip. So it gives us a kind of uniform way to build our system. So you as a builder, it helps you especially when you want to when you want to revisit the code. And as a consumer, it helps me to what to integrate into your API, to integrate your API. So that uniformity is very much more needed. So yeah, that has been seen. Let's see if you can. So it become more standard. It's clearly more organized, you see, but does not mean that resource oriented APIs are strictly better than RPC. Actually, no. For some scenario, RPC oriented will be better fit. This because designer provide. So what we have gotten out here is that in naming, let's have a resource. Let's follow that to the letter. What makes an API a good one? Yeah, I think let's stop here. Let's pick this one up next time. What makes an API? So what do we have to finish this chapter one? Blah blah. Yeah, it's still a long way. It's still a long way. Still a long way. Oh, you see now it's not so long. What's chapter two? I'm very interested in this. Introduction to API design patterns. What is an API design patterns? So let's see if I can come back after my break to finish chapter one. Then see you next time. So thank you so much for your time. Actually, yeah. So if you have any question, anything, I'm available. Thank you. That has been a wonderful 36 minutes of our time. All right, bye. See you on the next one. Next stream.